Hi, we're glad you're walking with us today. My name is Sophie, and I'm joined by Jack, and we're your student teachers for this lesson. We're joined by our teacher, Mrs. Fenn. Our goal is to keep your body moving to help keep your brain moving.
Remember that as you walk, only one ear should be covered with an earbud or headphone, so that you are still able to maintain an awareness of your surroundings. Got that? Keep one ear clear. Walk at a brisk pace, and make sure that you stay with your group.
So, let's get started. First of all, I hope everyone brought their umbrellas.
Why? Is it going to rain?
You tell me.
How am I supposed to know that? Is baseball practice canceled?
Is that how you tell what the weather's going to be?
Well, no, but they always seem to cancel it when there's going to be rain.
Yep, but how do they know? Who tells them when it's going to rain?
Well, that's easy. The weather person on TV.
Yes, but how do they know?
Well, I don't know. They look at the clouds or something and see what the temperature is. Or they watch the cows. My grandpa told me when you see the cows all lying down, that means it's going to rain.
Really? Well, you're right about the clouds and temperature, but there's a bunch of other stuff that they look at too. Studying and forecasting the weather is called meteorology. And no, it has nothing to do with meteors falling from the sky.
That's too bad. That would be really cool if meteors fell to the earth and told us what the weather was going to be. Ooh, or gave us a calendar of when it was going to snow, so we'd know if we had to do our homework or not. Sorry, Miss Fenn. I always do my homework, even when I think it might snow or school will be canceled. But you have to admit, a weather predicting meteor is pretty cool.
Actually, when a meteor makes it through the Earth's atmosphere without burning up and lands on the planet's surface, it's called a meteorite. But let's stick with meteorology, okay? So, Sophie, tell us what is meteorology?
I know that one. Well, I'd better, since that's my topic today. It's the study of the atmosphere and weather patterns. People who study meteorology and forecast the weather for us are called meteorologists.
You're right. So what do meteorologists look at to predict when it will rain and if baseball will be canceled?
They look at lots of things. Now they have radar and satellite images so they can see weather systems from way up high. They can watch which directions weather systems are traveling and know what weather is coming up for their area. They also have computer programs that help them create models of what kind of weather may be coming.
When you say models, do you mean little plastic clouds with little raindrops coming out of them?
No, I mean something like a computerized weather map that shows how all the different weather events that are going on at one time might affect one another and might cause something else, like a thunderstorm, a hurricane, or a change of temperature in a particular place. Every time you hear the weather announcers say there's a such and such % chance of rain or snow or something, it's because the computer has calculated that chance based on everything else that's going on.
So weather predictions are based on teaching the history of weather to a computer and letting the computer figure out how likely it is to repeat itself?
That's not a bad way to put it, actually. But before we had that technology, though, they watched temperatures and studied the clouds. And, Jack, your grandpa was onto something with the cow thing. Ancient people watched for signs from the animals to help them know when the weather is changing. Animals can sense very tiny changes in the atmosphere that we don't even notice.
Cool. But wait a minute. What makes the weather change all the time in the first place? Why isn't it just nice and sunny all of the time?
That would be awesome, wouldn't it? We'd never have to worry about a game being rained out or it being too cold to go outside.
Well, think about that for a minute. Maybe it sounds like it would be a good thing, but what benefits do we get from changes in the weather, besides getting to miss school when it snows? You know, I don't mind those unexpected days off either.
Well, I guess we need rain sometimes so plants and trees get water. And it might be pretty hot with no clouds in the sky.
Ooh, and if there was no change in the weather, there wouldn't be breezes and we couldn't fly kites. Unless, of course, rather than no breeze, there was always a breeze. And then that would get pretty old when you're trying to do something that's hard to do in the wind.
Like play badminton.
Exactly, you're right. But we haven't explained why our weather is constantly changing in the first place. Sophie, do you know?
Well, sort of. Doesn't it have to do with Earth being round and the sun's rays not hitting everything evenly?
Exactly, it does. The sun's rays hit the equator more directly than the polar regions, which makes the middle of the Earth much warmer than the areas north and south of the equator. Since the polar regions are at such an angle to the sun, they get little or no sunlight during the winter, and they have much colder temperatures.
But why would different places having different temperatures make the weather here change?
Well, it's because warm air rises and cold air sinks. This creates movement in the air and in the water, and it creates currents.
Right, that's what I was going to say.
Uh-huh.
Really, the current distributes the heat energy from the sun across the planet.
Sophie's right, Jack. When warm air rises, it draws in more air underneath it. Cold air sinks and pushes air outward.
Oh, so that's what makes the current. When warm air rises, it draws in more air underneath it. Cold air sinks and pushes air outward.
Right.
But why would the fact that the air moves make it rain?
I've got this one, Mrs. Fenn.
Take it away, Soph.
If I had a whiteboard, I could draw you a picture.
Well, maybe we can do that when we get back to the class.
Great, I'm a really good artist.
Haha, right. I've seen your stick figures.
Well, people are hard, but clouds are easier. So anyway, first, the sun heats up the ocean and makes some of the water evaporate into the air. As the water vapor cools and condenses, it forms tiny droplets that turn into the clouds. Once a lot of water has condensed, the drops become too heavy to stay in the air, and they fall to the ground as rain, or if it's really cold, as snow.
And then we get to miss school and go sledding.
Right, but that's not the end of it. Some of the rain or snow soaks into the ground and some of it flows back into the rivers and the ocean.
Sophie, that was a really good description of how rain works. But what about thunderstorms? Do you know what makes those?
Yeah, I love storms, as long as I'm not stuck outside in them.
I love storms too. I know that lightning has something to do with the electric currents in the clouds.
That's right. So inside a thundercloud that's way up in the sky are lots and lots of tiny ice balls, and they sort of bump into each other as they move around in the air. Their bumping into each other creates an electric charge.
Kind of like the static electricity when you rub a balloon on your hair and stick it to the wall?
No, more like when you shuffle your feet across the carpet when you're wearing socks and then shock someone with your finger.
That's exactly right. The cloud fills up with electrical charges, with the positive charges, which are also called protons, at the top of the cloud, and the negative charges, which are called electrons, they hang out at the bottom of the cloud. Have you ever heard the expression that opposites attract?
Like a magnet?
Well, sort of. Since opposites attract, it causes a positive charge to build up on the ground beneath the cloud. Remember, the negative charges are at the bottom of the cloud. The electrical charge on the ground concentrates around anything that sticks up higher than the things around it.
Like a mountain or a pole.
Or a person or single trees?
Yes, the electrical charge coming up from these tall things eventually connects with the charge reaching down from the clouds. And then what happens?
Zap! Lightning strikes.
Exactly. Lightning races to the earth at about 1/10,000th of a second.
Wow, you can't outrun that.
That's right. That's why when there's a chance of lightning around, you wouldn't want to be standing out in a field.
Or in any other high spot.
Absolutely. And do you know that lightning hits the earth 100 times each second?
Whoa, that's, let's see, a lot.
That's 8.6 million strikes every day and over 2 billion each year.
All right, Jack. Good math. Except it's actually over 3 billion each year. There are lots of other facts about lightning. Did you know that a single bolt of lightning is over 5 times hotter than the surface of the sun? That's about 50,000 degrees Fahrenheit, which leads us to lightning's best friend. You know who that is? We always see him together.
I know, it's thunder, but I'm not sure what makes the noise. Is it the lightning hitting the earth?
No, it's actually the surrounding air expanding and collapsing super fast because of all of that heat the lightning bolt generates inside a small hole in the air called the lightning's channel. thunder is the sound wave we hear when the lightning is gone and the air collapses back in. Does that make sense?
Yeah. So we hear the thunder after we see the lightning because it happens when the air collapses. After the lightning strike?
Ooh, I do know this one. The reason we see lightning before we hear thunder is because light travels faster than sound.
You're right. Lightning travels at the speed of light, which is about 186,000 miles per second. But sound waves only travel 1,088 feet per second, or about 1 mile in 5 seconds.
Whoa. Is that why you can start counting after you see a bolt of lightning and figure out how far away it struck?
Yep, that's right. Just start counting the seconds from the time you see the flash until you hear the thunder. Divide that number of seconds by 5, since sound travels about a mile every 5 seconds. So if you saw a flash of lightning and then you started to count 1,000, 2,000, 3,000, and you got up to 10, you would divide that 10 by 5, and you would know that the lightning struck 2 miles away.
Really? I thought that was just a joke.
No, it's science.
So I have another question. How far can the sound of thunder travel? I mean, we see lightning way in the distance sometimes.
That probably depends on how noisy it is where you are.
It does. It depends on the distance and the surrounding noise. If you're in the country where it's relatively quiet, then you might hear thunder from 15 miles away. In the city where you have so many other sounds, you might only hear thunder that's about 5 miles away. They call lightning that you can see but you can't hear heat lightning because usually when you see lightning from really far away, that means the sky is very clear and the air is very warm.
I think we kind of got away from our topic of meteorology, so let's rein it back in. Meteorology is the study of our atmosphere and weather patterns.
And it's important to understand the weather for many reasons, not just to know when to cancel school or baseball games.
Exactly. First of all, anyone whose income depends on adequate supplies of precipitation, that's a fancy word for rain and snow, needs to understand meteorology. And it's not just farmers. Think about people who run ski resorts and all sorts of outdoor recreation. And then there are people whose income depends on the absence of precipitation. People who operate state fairs and sports stadiums and landscapers and even teachers. But there are also airlines, private pilots, shipping companies and fishermen, bike riders. In fact, the more you think about it, the more you realize that knowing what the weather is likely to do is important to just about everyone. Every one of those people can do their job better if they can learn about the weather patterns in our atmosphere. And that's meteorology.
This has been very interesting, folks, but I think we're running out of time.
Okay, let me leave you with a little weather humor. What did one lightning bolt say to the other lightning bolt?
No idea.
You're shocking!
That's shockingly not funny. Don't quit your day job.
Day job? I'm only in 5th grade.
Yeah, well, stay in school.
Students, as you finish your walk back to class, take a look around. Notice the weather around you. Discuss with a partner what's happening in the weather today, and discuss with a partner the effects of air currents on weather. Remember, warm air rises and cool air sinks. How do you think that affected your daily weather today? And as always,
Happy trails!